Life.
Good morning, everyone, and thank you so much for joining us for the Moonbuilders workshop. For those of you who are new here, I want to give you a huge welcome. My name is Kevin Nielsen, and I'm a developer relations engineer at Moonbeam. If this is not your first Moonbuilders workshop, welcome back, and thank you so much for joining us. As you know, we do these workshops once or twice a month, and they're organized by Jimena from the Moonbeam team. Thank you so much, Jimena. Today, I have the distinct pleasure of being joined by Ben Carvalli, ecosystem lead at API3. And we will also be joined by Ashar Shahid, who's a core protocol dev at API3. He'll be joining us very shortly. Ben Carvalli spent 6 years in digital product design and build before working in fintech and joining API3 in early 2021. And Ashar has 7 years of development experience, and he joined API3 also in early 2021 on the core technical team. And he recently picked up responsibilities within developer relations. Now, API3 is a blockchain Oracle provider operating as a DAO, and API3 QRNG, or Quantum Random Number Generator, is the first-party quantum random number generator that is accessible as a public good for Web3. Now, API QRNG is a public utility. This is courtesy of the Australia National University Quantum Optics Division, and it's deployed on a number of different blockchains, including Moonbeam and Moonriver. Now, I'm not going to steal Ben and Ashar's thunder, but I do want to highlight the importance of on-chain randomness. On-chain randomness is critically important for a number of different applications: gaming, NFT mints, lotteries, and much, much more. Now, without Oracle providers like API3, there's no dependable source of on-chain randomness that can be reliably and truly random. If you're just getting started building a new application, it might be easy to say, hey, that block hash of the last block, that looks pretty random. Let's go ahead and let's use that. But upon further inspection and reflection, you'll realize that that is not a dependable source of randomness. In today's workshop, Ben and Ashar are going to introduce API3 and demonstrate how to use API3 QRNG within a dynamic NFT mint. So thank you so much for joining us for the workshop, and I'll go ahead and hand it over to you, Ben.
Thank you so much for the intro, Kevin. It's a pleasure to be here. And to start off with, just a quick thank you for the Moonbeam team for organising this and putting the effort in for kind of hosting us and kind of letting us talk a bit more around QRNG. So yeah, I mean, just to kind of recap, here's Ashar joining. Just to kind of recap, what we are going to run through is a quick intro to API3, a little bit of background around the QRNG feeds, and then hand that over to Ashar, who's just joined here, to kind of talk through a practical workshop of how you can use QRNG within an NFT mint. So let's get the technology to work, and I will jump straight in. Please, if you have any questions throughout this as well, please do feel free to pop them in the questions box. We will obviously pick them up and kind of go through them as per needed. So yeah, look, just a quick starting point to kind of give you some context around API3 and kind of how we've built the first party architecture that delivers these data feeds. So yeah, we are a DAO, which is a crucial piece in the puzzle in regards to delivering decentralized data feeds. We kicked off operations in late 2020. We're now a team of about 40 to 45, potentially a few more actually, as we've kind of been growing quite quickly recently. And yeah, as you may have guessed, we are an Oracle provider. And really what we focused on delivering is a first-party Oracle architecture. So yeah, just taking back a little bit of kind of history to Oracle's. The Oracle problem, as outlined in the Ethereum documentation, is that you need to have multiple sources of data to provide a decentralized feed. In kind of on the route of delivering that, I think there's also been some other challenges that have been introduced. And what we saw from the experience of kind of operating the Oracle world previously was that actually what we see is an API connectivity problem. And what that basically means is that there's no easy way, or there's no easy, simple way to secure, to connect Web2 APIs and make that data requestable by smart contracts. And ultimately, we believe that is restricting real world application and real world utility of blockchains. So we started off our endeavor to deliver a Oracle node that was open source, very lightweight. It can be deployed within hours, and it's, of course, with it being open source, free to use for API providers. And we called that Airnode. So what Airnode essentially does is it is deployed within the cloud architecture of that API provider. So when you request that data from that API, what you're actually requesting is, in effect, an Oracle that is being hosted or delivered by the API provider itself. And with that, you're bringing on chain the reputation of that data provider. So that's a high level kind of concept around what we're delivering, and in some ways that is a TLDR version. So on to introducing API3. So this is a data feed that was that saw Airnodes deployed to the Quantum Optics Division's API within the Australian National University. These guys have, I think, 10 years plus of quantum research experience. They set up an API, I think, 3 to 4 years ago. And effectively what we've done is just kind of had this conversation with them and said, look, randomness is a very valuable tool for builders in Web3 and for decentralized applications looking to use randomness. Would you want to kind of serve that vertical with the API that you've already got set up? And here we are delivering API3 QRNG. The quantum aspects of the randomness is basically, you can see Dr. Aaron Trentler there. So the team there used quantum theory to basically measure fluctuations within atoms as they clash in the laboratory, and then serve that through the API. Within the scientific community, it is a quantumly generated random number or color, or whatever you want to request. It's referred to as a true random number because the outcome of a quantum event is known to be the most uncertain thing that's possible within the world of physics, which I'm not a physicist, so if Aaron was here, we'd dive into that a lot more with a lot more detail. So API3, we deployed this as a feed, basically with courtesy of ANU, and we decided to make this a public utility. So it's accessible across 13 protocols. Of course, and Moonbeam, where all you need to do if you want to use the feed is basically allocate some Glimmer to a gas wallet, which sponsors the kind of gas fees as you request that data. And that's effectively all you need to do to access a service. It is permissionless as it kind of goes, really. The future will be looking to kind of onboard additional QRNG providers as Airnodes is kind of delivered new versions. We will be incorporating the developments there with the Oracle service as well. But high level on what that is. And if you want to use the feeds, then what you need to do is just follow these docs, very simply. And that's basically it. You will see within there information on how to request that from certain addresses, and there will be a Moonbeam or Moonriver wallet address in there. Ethereum smart contract address that you can just use to access that. And if you do, if there are any people here using it or any people that would want to use it, then please do let us know. We are keen to kind of help support you guys as you're looking to use the feeds. And of course, if you do have any interesting use cases, then we would love to kind of hear about them and understand how you're using it. And that is the kind of uninteresting part per se over. So I'm going to pass that back. I'm going to pass this now over to Ashar to jump into his technical workshop.
That was awesome. Just one quick follow-up question, if we have time. Can we go over the distinction between a first-party Oracle and a third-party, and why is it important that that API3 is a first-party Oracle?
Yeah, sure. So the distinction is essentially, a first party is going straight to the source of the data in its simplest form. Because Airnode is deployed within the API provider's cloud architecture, there is no middle layer transferring that data from the API into a multi-party node validator network and then onto the DApp, which means if you're a DApp, you can understand the source of that data transparently. You can gauge, if you're looking to aggregate data feeds for things like DeFi or the price reference data use cases, then you can gauge the quality of that data and you can decide how far you want to aggregate that data on an individual basis. The other aspect of being first party is that we, as a DAO, are going to be offering a service coverage product, which effectively will kind of underpin, or protect individuals or DApp owners against errors within these data feeds, which changes the incentive structure from what is a node validator, incentivizing somebody with operating that validator node to incentivizing somebody to provide reliable data and B, manage that feed accordingly. So there is no, if there are problems, they are kind of acted on quickly. That's first party.
I mean, like for third party, like you have these node operators that are serving the data, and that basically they have a consensus mechanism in their network that determines which node, like if the majority of the nodes are saying the truth or not, and they just, that's how they decide the validity of the data. And you don't really, that really isn't like the best way to decide the validity of the data if the source is only a single source. So like if say you get the, what's a good example of a single source? So like if you want the top album artist of this year, you would get that from a single source, which whoever releases those rankings, right? You wouldn't get it, like the node operators would call that source anyway. And so you have these 10 node operators calling the same source, getting the same data, and having this whole redundant network that is, you don't need that network. It's kind of redundant. And if in the case of say quantifiable data like prices or price feeds, you could do the aggregation on chain, and you could have the transparency of the source, like which sources. So you got the price from Binance, from FTX, from etc., and then you're aggregating it on chain. Given Moonbeam is a scaling solution, it's probably cheaper to do on chain than say on mainnet, but doing aggregation of quantifiable data on chain using median shouldn't be too hard. Like you take 5 values and you take the median value, and now that's your price.
Awesome. Yeah. Thanks, Ben and Ashar.
I mean, this was more like a practical explanation what I gave. Yeah,
that's great.
It's probably probably a better route to go down. Do you want to start, Ashar?
Yeah, I think we can start. So if we want, we can do it on Moonbeam itself. Like we can deploy the contract on Moonbeam and like have it mint on Moonbeam.
That'd be awesome, yeah.
But I need some Moonbeam tokens.
Tell me your address, or I will send you some.
I'll just post it in the chat. So.
Is there a certain amount that you need, or just
just like 0.1? That's fine.
Oh, sure. Yeah. And while I'm sending this transaction through, do you want to just make sure that your screen share and everything works okay?
Yeah, just give me a second.
Cool.
Sent you some as well, Ashar. Happy days.
All right. So let's get Uncharted. Can you see my screen?
Got it. Yep. Thank you.
Yes.
All right. So yeah, this demo is like just a demo on how to use QRNG, how easy it is to write a contract that can use QRNG um, within Moonbeam. And so if you're working on the Moonbeam chain and you need to have access to randomness, before you couldn't, but now using QRNG you have access to random numbers. And I'll be going through how you can use those random numbers to mint, say, like an NFT. So before we get started, let me just confirm that I have received the tokens. Or I don't have the RPC set yet. So
You can go to docs.moonbeam.network. I'll put the link here in the chat. And then there's a button at the top.
okay.
.network. Yeah, perfect.
So which one? The Moonbeam.
Moonbeam? Yeah, first one.
Cool. All right. Okay. Yeah, I think we're set. All right, so let's get started. The first thing that we want to do is we want to define solidity version. We can use above 0.8 for QRNG. I think you have to use above 0.8. So we are going to use the latest one, which is 14, I think, or 15. I think 15 recently came out. But we can go ahead with 14. And then we want to define 3 import statements. The first import statement is actually ownable, the ownable contract. So this contract is the Open Zeppelin ownable contract. It basically allows us to define a contract as ownable and give us access to ownable functions. I'll get into what ownable functions are, but for now, let's just import it. The second contract we want to import is the Erc721 contract. So this is the NFT contract that I think everyone is familiar with. This contract will help us, will define our contract as an NFT contract, and we can use the functions within it to mint NFTs. And finally, what we want to import is the RRP requester v0. So this is the contract by API3. What it does is it defines this contract, or we are going to call it demo NFT. It defines the demo NFT contract as a requester to the request response protocol. So the request response protocol is basically does what the name says. It makes a request and it gets back a response. And in this case, we'll be requesting a random number, and then we'll get back a random number. So now that we have that defined, what we can do is we can go ahead and define, we can like start writing the contract itself. So contract.
And before I forget, I just wanted to point out the typo for pragma.
Oh,
before we.
Oh yeah. Sorry. So yeah. So once we have that defined, we can just go ahead and do demo contract demo NFT is ownable Erc721 and RP requester v0. So yeah, that's it. And we can define the constructor. And the constructor will take a single address, and this is the address of the Airnode RRP protocol contract. So we need that address. as an argument to this contract. And we will pass this argument to our RP requester v0. So we will just pass on this address. And we also need to invoke the Erc721 contract. So let's just invoke it and give it two arguments. The first argument is the token name. So let's just call it demo NFT, and the token symbol. So let's call it demo. And once we have the constructor defined, what we can now do is define the functions that we'll need. So we'll need three functions. The first function is called set parameters. So what we do in this function is we basically set all the parameters that we will use in the request response protocol. So this will only be called once, and once it's called, all the parameters will be set, and they can only be changed by the owner of this contract. So since we want it to be changed by the owner, we'll give it the only owner modifier. One second. So it's gonna be an external and only owner modifier, and that's it for this function. We'll define all the functions. I'm just gonna write them down so that you have a holistic idea of what we are about to do. So set parameters is call to set the parameters of the request response protocol. And then we have two other functions. The first function is actually requesting the random number. The second function is the fulfillment of that random number. So here we will be requesting a random number. And here we'll be fulfilling the random number. Now, so we have these two functions, and this is basically the meat of the contract, like what you basically need in every QRNG contract. You need something that sets the parameters, you need something that requests the random number, and you need something that fulfills the random number. So in our demo, what we're going to do is we're going to create a very basic character, a character struct. And this character will be having some attributes that we'll set via QRNG. So let's give it strength and intelligence. And let's give it a name. So it's probably gonna be string. And now what we're gonna do is we are actually gonna mint this character using QRNG. So how that's gonna happen is we're gonna call request random, and request random will call our Airnode and get a random number, and then it's gonna fulfill that random number in this function. So the minting of the NFT will also take place in this function. So let's change the name of this from fulfilled random number to mint character, because at its core, it's going to be minting a character. So request random number will then become request character. So you can see how like the function name changes based on what's happening. But essentially what we're doing is we are requesting for a random number here, and then we are getting back the random number here and using that random number to mint a character in that same function. So now that we have the character defined, we can go ahead and define some extra variables that will help us in minting the character. So we have character array and public. Let's make public and let's call character. So we're creating an array of this struct, and so every NFT that we mint, we'll just push it to this struct, just to keep track of all the characters that we have minted till now. And now we need 3 variables for setting the parameters here. So those 3 variables are Airnode, and Endpoint Id, and sponsor wallets. I'll get into what each of these are, but for now, let's just define them. Now that we have these 3 defined, what we need to define are 2 mappings, 3 mappings, in fact. So mappings are this is going to be an address to Boolean mapping. And what this mapping is supposed to keep track of is that every time we make a request, what we're doing is we are waiting for fulfillment of that request. So we need to know if this request has been fulfilled or not. So we'll set a Boolean, so that if it is true, it means that it hasn't been fulfilled, and if it is false, it means that it has been fulfilled. So let's name it request, or let's name it expecting request to be fulfilled. And it's not an address, it's a bytes 32. Sorry about that. So every time we make a request in request character, what we'll get back is a request ID, and this ID will set it to true. So that means that the request ID is expecting to be fulfilled. So this request has not been fulfilled if this Boolean is true. Next, we need to define one more mapping, which basically maps the request ID to address. So this is the same as the last one, but instead of mapping it to a Boolean, what we're doing is we're mapping each request ID that is generated here to the address that actually created that request. So request ID to, let's call it sender. And finally, we need one more mapping, and this maps the request ID to the name that we'll be requesting here. So I'll get into that just a second, but let's call it right. So we have our mappings, our Airnode variables defined, our mappings defined. So now we can go ahead and actually define the functions. So for the functions, what we need to do is we need in set parameters, we need to set these 3 variables. So we will accept 3 arguments that will set each of those variables. So the first argument will be address underscore Airnode. The second argument will be bytes 32 underscore endpoint ID. And then finally, the final address will be sponsor wallet. And each of these arguments will be setting each of these variables. So it's just Airnode is equal to underscore Airnode. Endpoint ID is equals to underscore endpoint ID, and sponsor wallet equals to underscore sponsor wallet. So that is the set parameters function. It's pretty simple, not very complicated. But moving on, we need to define the request character function. And the request character function is pretty straightforward, but it might be a little hard to understand if you don't understand how Airnode RP works. So I'll go into a bit more depth on what's going on, but for now, let's define the arguments. So what request character is doing is it takes in a name. So we will give it a name, and we will then mint an NFT with that name. And so we just put in the name as an argument. And then what we will do is we will do bytes32 request ID equals to Airnode RP dot not underscore Airnode RP dot make full request, and now in the make full request we need to define a bunch of arguments, and it's I'll go through like what each argument we need to define is. So the first argument we need to define is called Airnode, and we've already set this here, so we don't need to manually supply it. And the second argument is endpoint ID. Again, we've set this. And third argument is the address of the sponsor. Now I will get into what sponsorship is, but for now let's just define address this as the sponsor. Next argument is the sponsor wallet, which we defined here again in this function. And the final address is the address of the contract that this request that we are going to make, where is it going to fulfill this request? So if you wanted, you could have it mint in another contract, but we want it to mint in this contract itself. So we supply the address of this contract. So the address this, but you could potentially call some other contract as well. And then finally, within this contract, which function do you want to call? So we want to call the mint character function. So what we'll do is we'll do this dot mint character dot selector. And there's one other parameter, which is the parameters you want to pass on to this request, and we don't want to pass on any parameters, so we'll just leave it empty. So that is the make full request function. Now there's a bunch of stuff that's going on here, and I'll get into each one of these now. So what is Airnode, right? Airnode is the address of the Australian National University's node that gives you the random number. Now, if you go to our docs, which is docs.api3.org, and you go to QRNG, and then you go to API providers, you see this address, the Airnode address. I'll just zoom in a bit. This address is the address of the Australian National University's node that serves us the random numbers. And this is the argument that we supply here. What is the endpoint ID? The endpoint ID is like the endpoint that you call within the Airnode. Think of it like in a URL. There are these paths, right? So if you have something like remix/images, that is one endpoint. But if you had say search, that is another endpoint. So you can have multiple endpoints in the URL. Similarly, in Airnode itself, you can have multiple endpoints. Now, we want to call the endpoint that gives us a single random number. But there are endpoints that can give you multiple random numbers. So if you see our documentation, this endpoint returns just a single random number. But this endpoint returns an array of random numbers. So if you wanted to mint multiple NFTs at once, you could do that as well. But we just want one and random number, so we're going to use this endpoint. Sponsor and sponsor wallet. Now, so what essentially happens when you call an Airnode is that you make a transaction that creates the request. Now, the fulfillment transaction that happens at the Airnode side needs to be paid for, right? The Airnode won't make the fulfillment transaction for free. You have to sponsor the request, and then after, by sponsoring, I mean like you need to transfer funds to the Airnode so that it is able to make that request, that fulfillment transaction.
And just so I understand, you don't charge any fees at all. It's just gas fees that you're sponsoring.
Yes. So yeah, these funds that you send to the Airnode, they're just gas fees. They're not any charges or yeah. Yeah, so you're not charging them for, say, the service or anything like that. This is purely the transaction cost that's going to happen that will fulfill your random number. So these funds are in the sponsor wallet. So you need to transfer funds to the sponsor wallet, and then the Airnode will use the sponsor wallet to make the fulfillment transactions. So that's how basically Airnode operates. And then the final two, I think I went over what each of these are. So this is the fulfillment address, and this is the fulfillment function within that address. So now that we have our request ID, what we can now do is just go ahead and set these mappings that we've defined here. So that's pretty simple. So expecting request ID to be fulfilled, give it the request ID, and set it to true. And then you have the request to sender, give it the request ID, and set it to the message.sender. And then again, request to name, set it to the request ID, and set it to the name that we took in as an argument to this function. So that's that. Let's make it a public function. And let's make it return the byte32 request ID. So okay. So that's our request character function defined. And now all we need to do is actually call the min character function. Now we don't want anyone to be able to call this min character function because we only want the Airnode to be able to call this because it's returning the random number that we need. So we're gonna give it an only Airnode RRP modifier, and yeah, so I think it's, you can double check. I think that's what it was. Yeah, okay. So only Airnode RRP modifier. So similar to the only owner, where only the owner could call this. We only want the Airnode RRP to be able to call this, because if anyone else would be able to call it, then they could tamper with their, like they could supply their own number and then tamper with the minting process. So
Sure. So we don't want anybody to skip the line, so to speak.
Yeah. We don't, like, if like, even if this was like an only owner thing, then the owner could, only the owner would be able to mint it. So we don't want that either. So we just want the Airnode to be able to call this. And what it would accept as arguments is the request ID that we generated here. So this is what the Airnode will fulfill with, and the actual random number itself, which will be in the form of bytes, which we will have to decode. But yeah, it's gonna be like this. So now we have this data which has the random number in it. So the first thing we want to do is decode that data. But before that, we need to actually check the mappings that we've set and see that if they are, if the request that we're trying to fulfill here, if it's actually waiting to be fulfilled. Because otherwise what might happen is you might end up double minting, because you say the blockchain Airnode sends 2 transactions back to back, and the first one gets fulfilled and the second one also gets fulfilled, because it saw that the request was on the logs for a long time without being fulfilled, so it sends 2 transactions back to back. So to avoid that scenario, what you can do is you can check here that you can add a require statement, which basically says that the expecting request ID to be fulfilled is true, and if it's not true, then request not waiting to be fulfilled. So if it's not true, just revert the transaction. And now we can go ahead and decode our number. So what we'll do is we will get the random number here in this variable or random number, and call API.decode and take in the data. And the data is in the form of a uint256. So we use this type to decode the data, and then that will give us back the random number that we have received. Now, using this random number, we can sort of set the attributes of a character that we are about to mint. So the ID of the NFT would be, let's see, it's gonna be the length of the characters array that we have here, that we're gonna push all the characters into. So the ID should be sequential in order, but the strength can be random number modulus, say 1,000, right? So the number we've received is a very, very, very large number. It's probably like 200 56 bits. So it's a very large number. But if we want it in a specific range, we can just do a modulus operation, save it 1,000, and now the number would be within 0 to 1,000 range. So let's keep our strength within that range, and let's also keep our intelligence within, say, 100 range. Of course, these are using the same random numbers, just to be clear. So they will more or less share the first 2 digits. But for the purpose of this demo, I think that's fine.
And if you wanted different random numbers, you could use the different endpoint, right? And you could get back multiple ones.
Yep. So this is not ideal, but let's just use this for now. But if you want multiple, yeah, like you said, you can just call the other endpoint. So now that we have this, we can push in the character that we have created. So the strength of this character will be strength here, intelligence here, and now we know the name as well. The name is request to name, and give it the request ID. So this is how you push struct in Solidity. Is you first define the struct itself, and then you push in the different variables of the struct that it's expecting. So it's expecting a strength, an intelligence, and a name. So a u into 56, u into 56, and a string. So you create that struct, and then I'm just pushing that struct into my array. And once that's done, all I need to do is actually call the safemint function that Erc721 contract gives me this function called safemint, and all I need to do now is mint it to the requester, the one who actually requested this request ID. So that information is stored in our request ID to sender mapping. So for this request ID, I will mint it to this address, and the ID of this token would be new ID. Yeah. So yeah, that's our mint character function, and I think that should be it. But say we want to actually view our character, we need a function that can help us view it. So view character, and this is going to take in a u into 56 token ID, and it's a public view function that basically return us characters token ID dot strength and characters token ID dot intelligence. Oops, just DID. And that should be it, I think. Oh, I missed the returns. Sorry. So let me just make sure everything is all right here. I think everything looks all right. So now what we can do is we can go over to here, 0.8.14 in the compilation tab, and try to compile our contract. And we have an error because obviously things don't work on first try. What's the error? Oh, my bad. So it's going to be a struct character and not a character struct. So. And then another error at line 26 because I forgot a semicolon. And one at 36. What do you have then? Oh, I forgot the right function. Sorry about these small mistakes. I'm not used to doing live coding. 3651.
Ashar, you're doing an awesome job. No worries at all.
Thank you. But now I'm confused on why this is an error. Expected this, but got returns. So if you think that you have problems, then like anyone watching, yeah, I do these type of mistakes as well. So don't worry. Like missing the semicolons and stuff like that. Okay, I think everything works now. Functions without implementation cannot have modifiers. Is it? Good because of this.
I think you can take out the semicolon, yeah.
Cool. Okay. And one last thing, I think. Still giving me that error. Identifier not found or not unique.
Oh, right before Airnode RRP, I think you can specify address in the constructor.
Ah, right. That should be fine. 38. Right. Okay. All right. So that took a while, but finally we are able to compile our contract, and it should work. So let me just try. Let me just double check one thing. But in the meantime, it looks like I've gotten the Moonbeam tokens. That's nice. Okay, so now what we can do is we can go ahead and actually deploy this contract on Moonbeam. So we'll go to the injected Web3. It says I have 0 Ether. I don't know why.
I think it's just, yeah, there we go.
Connect. Yeah, 2.1. Okay. So now we can go ahead and deploy this contract. So what we need to do is we need to get the Airnode RP address. And to do that, what we'll do is, again, we'll go to the docs.api3. We'll go to QRNG. We'll go to chains. And we'll look for Moonbeam. And Moonbeam is here. So we'll click on copy the address, and paste it here. Click on transact. And insufficient funds. Why did it say that? Weird. But yeah, it's deploying. While it's deploying, I guess if you guys have any questions, feel free to ask till now. But it's been deployed. So right now, Airnode is empty. Airnode RRP is the address that we've set. The endpoint ID is also empty. And the sponsor wallet is also empty. So the first thing we need to do is we need to set the request parameters. So we see the set parameters function. We need to call that. So we need to pass in the address of the Airnode. So the address of the Airnode is this address here in the documentation under API providers. So we copy that. We paste it in. The endpoint ID is this endpoint. We copy that. Paste it in. And now we need is the sponsor wallet. Now, for each requester or each sponsor, I would say, the sponsor wallet is a unique wallet within the Airnode. And there is a way to derive the sponsor wallet. The way you derive the sponsor wallet is you go to the docs. Again, everything is on the docs. You go to Airnode, and then you click on search, and you type in sponsor, and then you click on this last link here, and this is the command to derive the sponsor wallet. All you need is the Airnode's extended public key, the Airnode's address, and the sponsor address. Now, the sponsor address in our case is the contract itself, the address of the contract itself. And the reason is because the moment we imported RRP requester, we declared this contract as a sponsor of itself. So we can substitute the address of the contract in this command for the sponsor address. So let's go ahead and actually run the command itself. So let's call, let's open git bash. And within git bash, let's zoom in so everyone can see it. Let's copy this whole command and paste it in. Oh, wait, we need to change the values. So, but I don't know if it looks nice, but here we need to type in the Airnode extended public key. Now, where do we get the Airnode extended public key? Well, it's available again here in the docs. So beneath the Airnode's address is the Airnode's extended public key. Copy that. We paste it in. The Airnode's address, again, copy it from the docs. Paste it in. And the sponsor address. So,
and one thing to point out is that anybody can run this, on their computer. You don't have to be running a particular blockchain node or a particular Oracle service or anything like that. Just anybody can run this.
This is an npx command. So like you just you just need npx installed, Node.js, and if you have Node.js installed, you can run this command. You don't need anything like a blockchain or anything complicated like that. It's just a CLI command. Yeah, I think I should have made that clear. But this might look very confusing, but all you need to remember is that you need three things, and the three things, two of them you can get over here. They will never change. The final thing is the address of the contract you deploy if you use the RRP requester. So that's like a very simple way to figure out what you need to do. And so we got the sponsor address, and now all we do is hit enter, and all it's doing is just running this npx command, and it'll just spit out this address. Now this address is the address that will make the fulfillment transaction. That'll give us back our random number. And this address is on the Airnode side. And so we need to give it some funds. But before that, let's just put it here in the set parameters function. So we have the endpoint, the Airnode, and the sponsor wallet. So now all we need to do is click on transact.
Thank you, Ben. Thank you so much for the excellent presentation at the beginning, and we appreciate you being here.
Thanks, Kevin. You're too kind. Yeah, I'll leave you with.
Yeah, I mean, I'm almost done.
We'll be wrapping up soon.
Yeah. So,
okay, cool.
Yeah, I mean, we set the request parameter. Now, I think all we now need to do is actually just make the call for the random number itself. And the way to do that is you call request character here. And before that, we need to fund the sponsor wallet. Almost forgot. So let's just send it some funds so that it can make the fulfillment transaction.
Very important step. Don't forget, everyone.
Yeah. So you just need to paste in the address, and let's send it 0.5. And next, click confirm. And then failed.
Sometimes you just have to wait like half a second for the gas cost to be estimated. So yeah, let's just try that. Press next, and yeah, let's try. Should be fine. Maybe you could paste the address, and I'll fund the sponsor wallet.
Okay, I'll paste it here. One second. Oh, not that. That's my address.
Yeah, that one. Yeah.
Where was it?
Cool. Okay, it's pending. Should be done in just a second or two.
Mm-hmm.
Okay, confirmed.
Okay. I hope you send enough, but yeah.
I sent one full glimmer.
Okay, that's fine then. I think that should be enough. Because I saw the transaction cost, so I think it might cost like around 0.25 for a transaction.
Perfect.
So let's click on mint now. Not mint, but request. So let's call the request character function, which is over here. Let's give it a name. Let's give it, what's your name? Complete name?
My name?
Mm-hmm.
You say Kevin.
Kevin Nielsen?
Sure. Or you could do my username, which is, yeah, that's fine.
Oh, fine. So I have Kevin Nielsen, the first quantum random NFT on Moonbeam.
Yeah, no date of birth with social.
Okay. So it's pending. What's the Explorer page for Moonbeam? Do you know?
It's moonscan.io.
Moonscan.io. That's nice. Okay, so our request is successful. So all we need to do now is wait for the fulfillment. And that might take 6 block confirmations. So this is the request that we made. How many blocks?
Awesome.
It's 2 blocks. So until we have 6 blocks confirmations, the Airnode will not try to fulfill it.
And I think it's 3 on Moon River.
Yeah.
If I remember correctly.
I think so, yeah. Let's just see on chains. 3, yeah. Five. So 6 now. Airnode will probably pick it up and it'll try and fulfill it using the sponsor wallet. So let's see when the fulfillment happens. Yeah, if there's an error in the code, the fulfillment won't happen, but I've used this code before, so it should be fine. Yep, so.
Yes.
Yeah. Sorry. Sorry about that.
All good.
So let's see. Yep. So we fulfilled and we've minted token ID 0 using QRNG. And
Amazing.
If we go ahead and check the values in view character and we call 0. Yeah. So 282 and 82.
Oh, amazing.
Cool.
Thank you so much, Ashar. It's been an amazing demo.
Sure. If you guys have any questions at all, you can hop over to the API3 Discord and the dev support channel. And
do you want to post a link to the Discord in the chat?
Yeah, sure. Give me a second.
Or I can find one.
Yeah, it's fine. It should be on our.
If it's available on the website too,
Yeah,
it might be available from the doc site. Then
here.
Yeah, it's on the doc site. I see. Cool. Thank you so much, and we want to say a big thank you to Ben as well. Ashar, this has been wonderful. We went from start to finish, and you saw how easy it is to use API3 QRNG, and absolutely amazing demo. I'm thrilled that we were able to see all of this in action, and I'm sure others appreciated it as well.
Yeah, I mean the whole point was to show it me with all my slow typing and errors that even someone as incompetent as me can do it pretty easily. So it shouldn't be a problem for all the big brains at Moonbeam.
Thank you so much, Ashar. And make sure to hop in our Discord or in the API3 Discord if you have any follow-up questions. We'll be thrilled, to talk more there.
All right. Thank you, everyone.
Thank you so much.
Okay.